Just a second. Last lecture, where the names of agent of the thing. We have done all the questions of Williams and ether synthesis also, no? So right next, physical properties. Now, if you look at ether molecules, then ether we have alkyl group and then oxygen and then alkyl group like this. So these lone pair electrons, they are lone pair electrons, and that is why these are slightly polar. Okay, these are slightly polar because they have a dipole moment towards oxygen atom. Oxygen is more electronegative, that is why it is getting delta negative charge. Okay, so these are not completely non-polar, these are slightly polar. Right? Just slightly polar. No. Next, ethers have lower boiling point than alcohol. Due to absence of hydrogen bond. The absence of hydrogen bond in ethers.
Yes. So I'm ready.
They are saying something. Right, next. Boiling point of ethers are slightly higher than boiling point of ethers are slightly higher than hydrocarbons of similar molar mass. Why? Because ethers are slightly polar and hydrocarbons are non-polar. Next point is regarding the solubility. Ethers are soluble in water. Ethers are soluble in water as they can form hydrogen bond with water. Okay, so ethers, they don't have hydrogen bond between themselves, but for example, if you have something like this, you have HOH, and I have ether like this. So this hydrogen is delta positive, this oxygen is having lone pair electrons, and they can be forming a hydrogen bond. Okay, so this is how they are forming hydrogen bond. That is why these are soluble. Now, also one more thing is that is someone saying something. Sorry.
So unit 4, it's form now.
Hiram, I can't hear you at all what you're trying to speak.
So I'm saying that you wrote 4 here. It's form, right? Form hydrogen bond.
As they can form. form hydrogen bond here. As they can form hydrogen bond with water. Important point is that see, only the oxygen atom is involved in the hydrogen bond. These alkyl groups, these are hydrophobic. These are not soluble in water. Okay? These are groups. So if the R groups are very large, then the solubility will decrease. So please write increase in number of carbon atoms on alkyl group. The solubility decreases. Okay. These are very similar points regarding the solubility. It is very similar to that of alcohol also. Right? In alcohol also we saw that it can increase the number of carbon atoms in the alkyl group of alcohol, the solubility decreases. Now after this, please write chemical properties. In chemical properties, the first point is cleavage of CO bond. Cleavage of CO bond. Okay. Now this is the reaction with HX. Reaction with hydrogen halide. Okay. So please write treatment of ethers with HX leads to formation of corresponding alcohol and halo. And haloalkene. So basically, if I have R bonded to O, further bonded to R, and I treat this with HX, then obviously the hydrogen will be attacked by oxygen atom and the halogen will attach to the R group. So you will get alcohol, ROH, plus you will get RX. Alcohol, and if I see it is, this is R dash, please swap R dash लिख सकते हैं. So you get alcohol and haloalkene. Okay. Now, which alkyl group will make alcohol and which alkyl group will make haloalkene? That depends, but for symmetrical ether, it will not depend. So first case you will write for symmetrical ethers. For symmetrical ethers. So obviously it's for symmetrical ethers. For example, if you have CH3 bonded to O, further bonded to CH3 in the presence of HI. Now, you can attach anywhere the hydrogen. This alkyl group is going to give you alcohol, CH3OH, plus you can write CH3I. Don't have to worry about it in this case for symmetrical ethers. For example, if you have something like this.
Can you scroll up?
Yeah, sure. If I'm explaining and if you are writing something else, then I don't know like what is the use. You listen first, no? And then if you write HBr, if you're writing above and if I have started, then please ask me to wait. Huh? Now, Listen to this one and then you will write. Write the product for these. Send the answer on my WhatsApp. In symmetrical ethers, you just look at the alkyl group. So one of them HBr. Okay, so this is going to get OH and this one is going to get Br. Okay. Send the answer on my WhatsApp. Who was writing, please complete it. If I start a topic and you have not completed the previous part, please ask me to wait. Okay. The reason you are present in this class is to understand, not to copy notes. If copying the notes was your main duty, then I would have sent you the notes and you would have easily copied. That would have been even more efficient. Okay. So try to understand things in the class rather than just copying. Very good, Aaron. Both of these are correct. Gaba. No. See, Gaba, you're doing a mistake. Count the number of carbon atoms and then do it. Count the number of carbon atoms, Gaba. Tarif, yeah, correct, Tarif. Tarif, yeah, correct. Gaba, please count the number of carbon atoms and then send the answers once again. Nadiha, 1, 2, 3, 1, 2, 3, correct, Nadiha. You're doing mistake in the haloalkane part. Gaba, you're doing mistake in the haloalkane part. Gaba, you got the mistake, yes or no?
Yes, after attach one more carbon in both the answers.
There will be 2 carbons, right? This will be
Yes.
OH and Br. For this, you will have 1, 2, 3 carbon, and here you have
Your
this
voice is
methyl group,
cracking.
and then you have OH. Here also 1, 2, 3 carbon. Sorry. Hello. Can't hear you. Shahid. 1, 2. Shahid. Yeah, that's fine. But look at the second question's haloalkane. It's so bad. Try to write a bit more properly, okay?
So,
Yes, hello.
so your voice is very low.
My voice is very low. What about now? Is it fine, Kiran? Hello.
No, sir.
Nahin?
Speak again.
Actually, my internet is also not good because it has been raining for a very long time. What about now? ठीक हुआ कि नहीं ठीक हुआ? Still bad?
So it's not clear as well.
And it's low.
It's low. What about now? हाँ जी बताएं. Hello. Am I audible now? Is it fine? Can you guys hear me?
Yes, Anand.
Now you can hear me. All right. B part, that is for unsymmetrical ethers. Okay. Now, in unsymmetrical ethers, the first thing that you will do is, first thing, check if there is any three-degree alpha carbon. Check if there is any 3-degree alpha carbon. Then, if it is present, then attach halogen to that carbon. And the remaining fragment will form alcohol. Okay, so you have to first of all worry about the haloalkane. I'm giving you an example. So here you can see this is your alpha carbon. And this is also alpha carbon, right? Now this alpha carbon, it is 3-degree. This alpha carbon is only 1-degree. So if there is any 3-degree alpha carbon, if there is any 3-degree alpha carbon, just take that fragment. Okay, so if I'm reacting this with HBr, for example, then I will take this fragment here. So 1, 2, 3 carbon atoms, one carbon here, the other carbon is, it is like this. 1, 2, 3 carbon atoms. Okay, 1, 2, 3 carbon atoms, and the fourth carbon is above. Fine. And this is the alpha carbon. Here you will attach the Br. And what is remaining? 1, 2 carbon and oxygen. 1 and 2 carbon, then H. All of you got this? You're going to please tell me. Anji, बताएं. What you need to see is just
Yes, sir.
if there is. Tell me.
So, so please repeat now.
Once again.
Yes.
Let us suppose you have CH3, CH2. CH2 and oxygen. This is further attached with carbon. Here you have CH3. Here you have CH3. And here you have CH2, CH3. First of all, identify the alpha carbon. I'm writing some numbers here, okay? 1, 2, 3, 4, 5, 6, 7, and 8. So tell me what is the alpha carbon here?
4.
Which is, sorry?
4.
2,
4. 4.
3. आपकी आवाज नहीं आ रही
Sir, I'm saying 4. 4.
4. बस और कोई है या फिर सिर्फ 4 है? Is there any other alpha carbon? Any other alpha carbon? I think Tariq has sent the answer. Tariq correct. Any other alpha carbon, guys? आगे लोग बताएं मदीहा, प्रभात, शाहिद, शावेज, फहद. T is also alpha, na? You can see that, right? T is also alpha, right? Yes or no? Iram? Iram?
Yes, sir.
Okay, T is also alpha. Now, what is the degree of 3? This alpha 1 and this is alpha 2, let us suppose. Alpha 1 पे क्या है? What is the degree of alpha 1? 1 degree या 2 degree? 3 degree? जल्दी बताए ना. How much? Shaveez? 1 degree, right? And what about alpha 2?
Alpha 2 is
What about alpha? 3 degree. Okay. So you will break this bond and this fragment will get what? Halo, alkene, then the halogen or the hydrogen. 3 degree वाले को क्या मिलेगा? You check if there is any 3 degree alpha carbon, then attach halogen to that carbon. 3 degree carbon में क्या attach करना बताइए? What you need to attach on the 3 degree? Halogen. What is the halogen? है ना? So halogen that you are going to attach is, for example, HI. We have 1, 2, 3 carbons. So 1, 2, 3 carbons. This third carbon will get the halogen, iodine, and you have CSP, CSP groups here. It will come. I don't think this is correct. Third carbon, so this is going to be here. CS3 and CS3. 1, 2, 3. 1 and 2 carbons, right? And what about this? This is going to get OH. So 1, 2, 3 carbon atoms. And then OH. Got it? Yes or no, please tell me. Anji, all of you got this? Yes or no?
Yes, sir.
Yes, sir. Okay. Please write this down. Iram, you understood this now?
Yes, sir.
After this, you look at mechanism. Write this quickly. Let me know once you're done.
Done.
See the mechanism. I'm taking the previous case only. So in the previous case, we had 1, 2, 3 carbon atoms. Then we had oxygen. Then we had carbon atom and 2 more carbon atoms like this. And this carbon atom had CSC and CST. Okay, so we have oxygen like this with lone pair electrons. Plus we will get HI, let us suppose. Hydrogen will be delta positive, iodine will be delta negative. You can also write directly H positive because hydrogen iodide can easily break up. Right, so you will have H plus. Oxygen molecule is going to attack here, leading to the formation of what 1, 2, 3, and then oxygen 1, 2, and 3, and then you have the CH3 as it is. Now the oxygen is going to get the hydrogen also with a positive charge. Now, as soon as it gets positive charge, this 3 degree alpha carbon, it will break off. Okay, it is going to break off. So as it will break off, it is going to form 3C, 1, 2, 3, and then you are having OH plus 1, 2, 3. and it is having CH3 and CH3 like this. This is having two CH3s with a positive charge. It has become a carbocation now. Now, from here, what is going to happen? Let me just replace this here and here. Now, after this, what is going to happen? The iodine is going to attack. I negative. I negative is going to attack on this carbon atom, leading to formation of the CH3 and CH3 are as it is. Already got this? So why it is forming 3 degree? This is 3 degree carbocation, which is more stable.
Sir,
Mhm.
sir, here in second step, oxygen took electrons from the stable carbocation.
Here, this one, this arrow.
Yes, sir.
See, here actually what is happening? This is a
Yeah,
positive
like,
charge, right?
yes, sir.
This is a positive charge, right? So this
Yes.
positive charge is present, so it is going to pull electrons from what? From the carbon atom. And it will be so effective in pulling the electrons from the carbon atom that this particular bond is going to break off. And when it break off, we get a stable molecule that is alcohol, and we also get a stable carbocation. But this positive charge on oxygen atom is very, very unstable because oxygen is a electronegative element. It can bear a positive charge. It can only be, if you give it negative charge, it can, even though it will be unstable, but still it can bear a negative charge. But oxygen can never bear a positive charge because it is what it is, electronegative element. Okay. That is why it breaks off and we get alcohol stable. And then we get a positive charge on carbon atom, which is much more stable than positive charge on the oxygen atom. Got it?
Yes, sir.
Okay, so this was the case of if you have at least one fragment which is 3D, and if you have one 3 degree fragment, then what you are going to do? Right, next.
Yes, yeah.
लिखिए. Let me know once you're done writing.
Yes, sir.
All of you done? Anyone still writing? Okay. Now write please. The second possibility, if only 1 degree or 2 degree alpha carbons are present, then the is right, then the alkyne group with lower degree will get halogen. Okay, and the rest of the fragment will form alcohol. Okay. So, for example, okay, so identify the alpha carbon. This is alpha. This is also alpha. No, this alpha, it is connected to one carbon, two carbon. So this is 2 degree. This one is 1 degree. This one is 1 degree. So what is going to happen? If I treat this with Hi, the 1 degree will get halogen. You will have two carbon atoms and then iodine. Plus this whole fragment is going to make what? Alcohol. 1, 2, 3. Here we have CH3 and then you have OH. Understood? Yes or no, guys? Tell me.
Yes, sir.
Okay, so generally, आप याद रखिए, if it is not 3 degree, then the smaller fragment is going to get halogen. For example, if you have something like this. Okay, now in this case, both of these alpha carbon, this is also 1 degree and this is also 1 degree. Okay, now if both of them are 1 degree, then the smaller fragment will get the halogen. So here the smaller fragment is this one. This is going to get halogen, 2 carbon atoms and then iodine. Here we have 1, 2, 3, 4 carbon atoms and then OH. Okay. Can the answer for this one? All of you done, please tell me. Can the answers, right? Can the answers? Identify the alpha carbons and then the smaller fragment is going to be halogen. Carbon. Okay, 1, 2, 3. Yes, I'm correct. Very good. Jasola is 1, 2, 3. Yeah, correct. Very good. Okay, guys, please see here. Also 1 degree. This is also 1 degree, right? Both of these are what? 1 degree alpha carbons. So obviously the smaller fragment will get the iodine. So 1, 2 carbon atoms in the smaller fragment plus the remaining portion 1, 2, 3, 4. तो ये पहले वाला सवाल कर दिया my bad. Which the answer नहीं आया बच्चों का. Still students are not answering. Okay, it's just that I have started like this and it's a bit different. Here we'll have like this. Done everyone? Yes or no? Please tell me. Write this down quickly.
Done.
Okay. Let us suppose you have alkoxy benzene. Or any R group here, okay? So please see, this is very important. है ना? इसको भूलना बिल्कुल नहीं है आप लोगों को. See, this is oxygen. It will be having lone pair electrons. It will be in conjugation with the benzene ring. So this particular bond, it is going to have partial double bond character. So obviously you cannot break this bond. If you cannot break this bond and you're reacting this with HI, then for sure you will be forming OH. And the R is going to get RI. Okay, so please write alkoxy benzene forms phenol and haloalkene. No matter what type of thing you have here, if you react this with HI or HBr, then this phenol will be always there. Plus, you have 1, 2, 3 carbon atom. And in the middle carbon, you will get hydrogen. Can you write this down? Third case, please लिखिएगा. So here also you can use the smaller fragment concept. Third case is also important. Please write the third case. Benzyl alkyl ether. You have benzyl alkyl ether. What is benzyl alkyl ether? If you have a benzene ring attached to CH2, this is benzyl group. This CH2 is further attached with oxygen and this is further attached with R. Okay, so now this carbon oxygen bond can be easily broken. And if you are going to break this, it will form CH2 positive here, which will be in conjugation with the benzene ring. That's why it will be forming a stable. It will be forming a stable carbocation. So if you react this with HI, then you will get benzyl halide. ठीक है. Similarly, यहाँ पे देखिए, if you have benzene ring attached with CH2, benzyl, if you see the benzyl group, then the benzyl group will always get the halogen. Even if you have something like this, CH2, oxygen, and then further you have another benzene ring. Now you can answer this in two different ways. If you have oxygen with benzene ring, तो पक्का ये क्या बनाएगा? Phenol बनाएगा. It is obviously going to make phenol, right? And if you have CH2 attached to benzene ring, then पक्का ये क्या करेगा? Hydrogen attach करेगा, right? So you can answer this question in both ways. You'll have the benzene ring with CH2. I'm using hydrogen iodide, and iodine will attach. Plus, in this benzene ring, we'll be attaching the OH. All of you understood these questions? Yes or no? Please tell me. तो समझ में आया? बोलो भाई।
Yes, sir.
What about others? ठीक है, ध्यान से
Yes,
आप
sir.
लोग एक स्टेप ना ऐसे बिल्कुल आप लोग फोकस करके पढ़िए, ठीक है? ध्यान से भटकने मत दीजिए। थोड़ा सा भी अगर आपको लगे कि समझ में नहीं आया तो कैसे बोलिए, आई विल एक्सप्लेन इट वंस अगेन, ओके? So what
Sir,
I
I want
will
to
write
know.
here. Sorry. साफ साफ बोला था, नहीं पता नहीं क्या हो गया जरा। You said something.
Yes, sir, her voice is very low.
My voice is very low. Is it for everyone? Shahid, Shavez, am I audible properly?
Yes, sir. Yes, sir. Sometimes it's slow.
Sometimes it's low. Here it is. Now, what we can write? When we are reacting benzyl alkyl ethers, then what is the product? We'll always get benzyl halide. Please write benzyl halide is formed. Because reaction occurs via SN1. Reaction occurs via SN1 and benzyl carbocation is very stable. Now, write the fourth one, that is diaryl ethers. What is diaryl ether? You have benzene ring, oxygen, and then again a benzene ring. If you react this with HI in presence of a bit heat, no reaction happens. Why? Because both of these bonds are partial double bond. Oxygen is showing resonance with both the benzene rings. Okay, so please write.
Sir, can you scroll?
Diaryl ethers don't show reaction with
Yes, sir.
with HI, oh, sorry, HX in general, with HX, because both CU bonds as partial double bond as partial double bond character due to resonance. And difficult to break. All of you done? Yes or no, please tell me. Okay, so in this case, that is ether with HX, we have seen different cases. If there is a 3-degree alkyl group, then 3 degree का bond के साथ halogen के साथ, and rest will be with alcohol. If there is only 1 degree or 2 degree, then what will happen? Smaller fragment will make haloalkane. Then if you have something that is alkoxybenzene, then in that case, phenol plus RX. Now, if you have what this was I think 5th case. Diaryl. Now, if you have benzyl alkyl ethers, CH2, OR, then in that case, what is going to happen? You'll have benzyl halide, CH2X plus ROH. If you have pH, oxygen pH, that is benzene O and benzene, then there will be no reaction. Okay. So that is the summary of the reaction of ether with HX. After this, we have, please write, electrophilic aromatic substitution of anisole. Electrophilic aromatic substitution of anisole. Right here, alkoxy group is an activating group which increases electron density of benzene ring at ortho and para position. Leading to formation of ortho para products.
So this is chemical properties, right?
In fact, chemical properties only. We're looking at reactions only, right? Electrophilic aromatic substitution of anisole. Please see. Something like this. Okay, wait a second. You have to make bonds here because we need to show resonance. These lone pair electrons will move here. This pi electrons will move here and make a negative charge, which will give us oxygen R with a positive charge here. This bond will be as it is. This bond will be as it is, and there will be a negative charge here. Moving on, this particular negative charge will move here on the para position. Now, this bond is as it is. This is a new bond which is formed. This double bond oxygen will get a R group with a positive charge. Okay. Now the negative charges here. You can make other resonating structures also, but we have got our case that my resonance hybrid structure will have the OR as it is, This will be, all these bonds will be partial double bond. This will be having delta negative. This will be having delta negative. Also, because it is also ortho position, this also will be getting a delta negative charge. Okay. As you can see, the electron density is increasing at the ortho and para position. I hope you know how to make the resonance hybrid structure. You just need to look at the bond. Say this particular carbon
Can you scroll up?
atom, it is neutral, but here it is negative. It is again neutral. So sometimes it is negative. That is why it is going to be delta negative. Okay. So please write this down. Then we will look at the reactions. Want to put any one of these in me? Done? Not done. Let me know if you're still writing.
Can you
See
scroll
here.
up that last?
Yeah, sure. Guys, please revise these things, okay? If you are not going to revise, and like sometimes what you will see is when you are doing the class, then you may understand a particular point very perfectly, okay? And when you go back to revision, that same point will be not very easy to understand, okay? So that is why I asked that revise daily. So if you are revising daily, you will be, if you are getting some doubts, those doubts will be cleared up. Otherwise, if you don't revise daily, then at the end, it will seem like all of these things should be memorized. But I hope you can see that everything is not to be memorized. There are logics for everything. For example, this particular topic, electrophilic aromatic substitution, it is present for haloalkane, not haloalkane, halorine. It is also there for phenol. It is there for ether. It will be there for benzaldehyde. It will be there for acetophenol. It will be there for benzoic acid. It will be there for aniline. So you will have 7 different substrates with the same reagents. And the formation of product is also same. The groups which are attaching, they are same, but the position may differ depending on the electron donating capacity or the withdrawing capacity. Okay, so at least for electrophilic substitution reaction, don't try to memorize these things. Try to understand the electrophilic aromatic substitution reaction. Okay. For example, if I take anisole, which is benzene ring, which is connected to OCH3. Obviously, it is ortho-para-directing. We have seen how it is ortho-para-directing. If I react this with a halogen atom such as Br2, okay, please see. So we have Br2, and you don't need anything. You just need acetic acid as a solvent. CH3COH. Okay, but CH3COH is not taking part in the reaction. It is present as a solvent only. Now OCH3 will be as it is. You will get a Br group on the ortho position, and you will get another product, OCH3. Achha, if I write like this, I hope you guys will not have any problem now. Please see. If I write OCH3 like this, and the Br here, I hope all of you understand that this is also para. Yes or no, guys? Please tell me. All
Yes,
of you
sir.
understand that this is also para, right? Now, See next. So let me just copy these two. This here is. Next we are taking CH3Cl. In the presence of anhydrous AlCl3. This is Friedel-Crafts alkylation. So this OCH3, everything will be as it is. Here you will get CH3 because it is alkylation. Similarly, for this case, what you are going to get in the para position, you will get CH3 also. And in the para position also, you are going to get CH3. Now, next, if I do acylation, that means CH3, C double bond O, which is bonded to chlorine. In the presence of again AlCl3. So here what you are going to get the anisols, benzene and OCH3 as it is. And then you will get C double bond O CH3. Plus you will get OCH3 as it is. And in the para position, you will get C double bond O CH3. At last, we will do nitration, that is HNO3 in the presence of concentrated H2SO4. In this case, you will get the anisole as it is. OCH3. And here you will get NO2 in the para position, sorry, ortho position. And here in the para position also, you are going to get NO2. Okay. Now all the para products are major. Okay, all the para products are major. हिरम आज आप क्लास में नहीं आए थे सुबह? हिरम,
Sorry.
you did not come to today's class solution chapter.
I had tuition.
Just one teachers for okay.
Yes.
By the way, I don't know. 17, 20. Is there anyone whose school is starting on 21st of August? Anyone whose
Yes,
school
sir.
is is after start हो रहा है? Nadia, you're also. Nadia, you have done solutions with me, na? What? Shahid also.
Yes, sir.
What about you guys, Shavez and Shahid? You guys have done solution with me or not?
No, sir.
Recordings भी नहीं. Recordings. What about recordings?
That I have to see, sir.
नहीं तो फिर अटेंड किया अच्छा तो फिर आप लोग 2 क्लासेस और कर पाएंगे दैट इज ऑन सैटरडे एंड संडे लेकिन सैटरडे संडे तक तो कम क्या करेंगे all of you done listen to PCL
Sir, here how para products are major products.
ये अगर आपको जानना है तो पीसी ऑक्सीजन Okay, and then comes the electrophile. This is having delta negative, and this is also having delta negative, right? अच्छा, I hope also अब ये नहीं कहिएगा सर यहाँ पे अटैक हो सकता है, because this particular bond can be, it is movable, right? It can move around, and this CH3 can be here also, so it is rotating always. Okay, this bond can be rotating. So as you can see, there is steric hindrance in the ortho position. It is not very easy to attack from the ortho position, right? But para position is quite free, so para can easily attack and make the major product. Got it? Yes or no? Tell me.
Yes, sir.
Okay, steric hindrance की वजह से. Right, next. फहद को लगा कि क्लास खत्म हो गई. क्लास खत्म नहीं हुई अभी. मेन पॉइंट तो बाकी. Please write remarks. Remarks first point, please write. Anisole undergoes bromination in the absence of FeBr3 catalyst because the methoxy group is highly activating. Okay, so benzene is so reactive, the benzene ring in which methoxy is added, it is so reactive that the reaction, the bromination reaction, it does not even require any catalyst. Right, the second point. Anisole doesn't undergo sulfonation because the presence of, rather it is because in presence of concentrated H2SO4, the ethereal oxygen gets protonated and the benzene ring is deactivated. Okay, so what happens? Please see. I have anisole. Here we have H2SO4 concentrated. Obviously, there will be H plus ions, and this oxygen atom, it has lone pair electrons which can attack on the hydrogen. That is why it becomes oxygen with CH3 and then hydrogen, and it becomes positively charged, which pulls the electron from the benzene ring, making it deactivated. And if it is deactivated, then what's going to happen? It will not have enough electron density in the benzene ring to attack on electrophiles. Okay. And by this,
So electrophile doesn't attack.
sorry, क्या हो रहा है आपके यहाँ? गिर पड़ गया क्या आप शावेश? शायद कौन है? शावेश?
So electrophile, yes, sir. Electrophile doesn't attack.
Electrophile? See, electrophile is
Doesn't attack.
electron. No. One thing जनरली ऐसा आप लोगों को लगता है, यू गाइस मस्ट फील दैट जो छोटी चीज होती है वो आके ऐसे अटैक करेगी, राइट? बट इन केमिस्ट्री वी हैव अ रूल दैट ऑल ऑफ द अटैक्स आर डन बाय इलेक्ट्रॉन रिच स्पीशीज. So obviously the electrophile is, it is electron deficient, so it cannot attack. Okay, so this is actually attacked by the benzene ring, है ना? लेकिन हाँ बात वही सेम है, ठीक है, बस बोलने का तरीका अलग है. So electrophile cannot attack on the benzene ring because benzene ring जिसको बहुत ज्यादा इलेक्ट्रॉन रिच समझ रहा था वो इलेक्ट्रॉन रिच रहा नहीं. It is being deactivated because oxygen got a positive charge which is pulling electrons from the benzene ring. Okay, so if it is deactivated the reaction will not happen. So you can do reaction but it will not happen in normal conditions, है ना? आप हीट करेंगे, प्रेशर ज्यादा करेंगे, then it can happen. ठीक है, by this the second chapter of organic chemistry is over. ठीक है, अब जिन लोगों का बैकलॉग है ना, प्लीज स्टार्ट कर दो पढ़ना आप लोग. हालो अल्केन भी बहुत सारे लोग होंगे, हमको पता है. हालो अल्केन के सारे एनसीईआरटी के क्वेश्चंस हुए नहीं होंगे अभी तक. हमने ऑर्गेनिक कन्वर्जन्स का भी वीडियो भेज दिया है, उसके बावजूद बहुत सारे लोगों ने नहीं देखा हुआ होगा, है ना? और ऑर्गेनिक कन्वर्जन आ जाएगा. ठीक है, कोई चीज नहीं छोड़ना है ऑर्गेनिक केमिस्ट्री में. आप ऑर्गेनिक केमिस्ट्री इज हाफ ऑफ योर मार्क्स.
Sir, organic conversion is important.
It is important and it is the best thing to revise the reactions. You know, it is the best thing to revise the reactions. That is, इसीलिए तो हमने हालोल्किन हालोजिन के लिए अलग से बिल्कुल बताइए, वरना just imagine कि कितना, it took almost like 1.5 hours to complete halalkin halorines organic conversion. But please watch that lecture, watch that multiple times, because if you are going to be a good, I mean, if you can convert from in the halalkin halorine, if you can do the conversions, then you can easily do the conversions in the next chapter. Okay, but if you did not do any conversion in haloalkene halorine, thinking that we have so many conversions, haloalkane halorine, I think it has the maximum number of conversion, that is 30 approximately, 30 or 28, something like that. Okay, so if you saw that number and you got scared, then the next chapter also will be, there will be difficulties in the next chapter also. Okay, so please watch that video of organic conversions, complete your NCERT. Most of the Y type of question, most of the, what I will say, all the Y type of question, and even more than NCERT we have done in the notes. So all the Y type of questions will be completed. Another thing is that, again, I'm telling you guys to prepare sheets, short notes. Method of preparation. Chemical properties. Y type of questions. Name reactions. और जो अगला बहुत ज्यादा नेक्स्ट चैप्टर में काम आने वाला है, दैट इज टेस्ट्स. व्हाट टेस्ट? केमिकल टेस्ट्स, है ना? टू डिस्टिंग्विश बिटवीन फेनॉल एंड अल्कोहल, है ना? तो शायद हमने आप लोगों को लिखाया था दैट you can use what litmus paper, right? For phenol, 1 degree alcohol versus 2 degree alcohol versus 3 degree alcohol, and how to differentiate Lucas reagent. Okay, so these type of conversions. So you should have at least these pages. MOP and CP, you will have haloalkene, haloadenine, alcohol phenol ether, and aldehyde ketone carboxylic acid. I mean, so into 6 and into 6. Okay. Y type of questions, you will have only 1 page. So this will be 6 pages, 6 pages. This will be only 1 page, maximum 6 pages. Okay. Try to condense it in single pages only. 6 pages is also, I mean, enough. 1 page, and it will be chapter wise. You will just write the questions. You don't need to write the answers. Answers should be either in the notes or in your brain. All of these things are for revision. And if you are going to make these sheets, then in organic chemistry, you will surely get 90%. Get 90%. Okay. More than 90% in organic chemistry is confirmed if you are going to make these sheets. I am not saying that if you are going to copy these sheets from internet, you will get all of these things. Now, method of preparation, mind map, and chart. If you Google these, you will obviously get all of these things. But if you are going to put some work, then only it will be there in your brain. If you are going to prepare it yourself, that is the right? Okay. टीचर्स के मतलब टीचर्स के दिमाग में इतना ज्यादा क्यों रहता है? बिकॉज वो उनके नोट्स होते हैं, है ना, मतलब उनको पता रहता है क्या चीज कहाँ पे नहीं है। ईच एंड एवरी टीचर दे हैव डिफरेंट टाइप्स ऑफ नोट्स, उसी वजह से उनको सारा का सारा चीज याद है। आप टीचर के नोट्स को लेके अपना नोट से बनाएंगे तो ऑब्वियसली वो आपको याद रहेगा, है ना, और खुद को समझा समझा के, ठीक है। ट्राई टू एक्सप्लेन थिंग्स एंड रीड, एंड व्हाइल यू आर एक्सप्लेनिंग तो आपके वहां पे डाउट्स आएंगे, ठीक है। अब फिर उसके बाद आप डाउट्स पूछिए। एक तो चीज यहाँ पे है 12th क्लास की केमिस्ट्री में रिएक्शन मैकेनिज्म्स का मतलब के ऊपर बहुत ज्यादा चर्चाएं नहीं है ना। देयर इज नॉट, I mean, you don't have any details of the reaction mechanisms except in few cases of SN1, SN2 elimination. बस ये 3 ही रिएक्शन मैकेनिज्म है जो आपकी टेक्स्ट बुक के अंदर है। क्या क्या? SN1, SN2 एंड एलिमिनेशन, दैट्स इट, ठीक है। लेकिन उसके बावजूद आपको अगर कहीं पे कंफ्यूजन आ रही है रिएक्शन मैकेनिज्म में कि सर ये प्रोडक्ट कैसे आया, ये प्रोडक्ट क्यों नहीं आया, अगर आपने इतना आपने अगर दिमाग लगाया है तो प्लीज यू कैन आस्क दैट आल्सो, ओके। बट ये चीजें जरूर कर लीजिएगा, वाई टाइप ऑफ क्वेश्चन पे एक पेज चैप्टर वाइज, है ना। यहाँ पे ऐसे होगा एल्केन हैलोरीन ऑल द वाई टाइप ऑफ क्वेश्चंस, अल्कोहल फिनोल ईथर्स यहाँ पे, एल्डिहाइड कीटोन्स के लिए यहाँ, अमीन्स के लिए, इस तरह से यू विल फ्रैगमेंट दिस। अगेन नेम रिएक्शन आल्सो यू विल मेक अ लाइन लाइक दिस, एल्केन हैलोरीन के लिए दीज आर द नेम रिएक्शन, यू विल जस्ट राइट द नेम्स। इतनी दफा हम बता रहे हैं आप लोग को, आप लोग सिर्फ नाम लिखना है, ठीक है। केमिकल प्रॉपर्टीज, केमिकल टेस्ट में भी वही कि हैलोल्केन हैलोरीन में कोई था या नहीं था, इफ देयर वाज एनी केमिकल टेस्ट और नॉट, ओके। सो प्लीज प्रिपेयर दीज शीट्स, अभी भी जिनके पास वक्त है समर वेकेशन खत्म होने से पहले पहले प्लीज थोड़ा टाइम लगा दें, है ना। बिल्कुल कमर बांध लीजिए आप लोग, कुछ दिन जो बचे हुए हैं खास तौर पे उनमें बहुत अच्छे से फोकस कीजिए, और इंशाल्लाह फिर तो मार्क्स आएंगे, है ना। रिविजन करते रहना लेकिन आप लोग को, ठीक है। चलिए दैट्स इट फॉर टुडे, एंड होपफुली कुछ रिविजन क्लासेस आप लोग की रखी जाए फॉर द मिड टर्म एग्जामिनेशन, हाफ ईयरली एग्जामिनेशन जब भी आप लोग का हो रहा है ना। एंड ऑब्वियसली वो तो क्लास के टाइमिंग्स में हम नहीं रखेंगे। अनदर थिंग दैट इज आफ्टर द समर वेकेशंस आल्सो सैटरडेज आपकी छुट्टी होती है, ऑल ऑफ यू आर हैविंग सैटरडेज ऑफ ना?
Yes, sir.
एनीवन हु डजंट, हाँ सॉरी सैटरडे ऑफ ना या नहीं ऑफ?
No, sir, I have a special class.
You have what class?
Special classes.
Special classes.
Yeah,
So
sir,
you
even
go
me.
there. अच्छा ठीक है, फाइन। You go there, you learn something, या फिर आप सिर्फ जाते हो?
No, sir, they teach.
अरे दे टीचर्स वो तो ठीक, हम लेकिन क्या आप जो पूछ रहे हैं आई होप यू अंडरस्टैंड। सो आप सिर्फ जाते हो या सीखते हो वहां पे?
We learn.
सॉरी,
We learn.
यू लर्न ऑल्सो, ठीक है। अगर आपको बेनिफिट हो रहा है तो ठीक है, लेकिन आई एम प्लानिंग टू कीप लाइक एवरी सैटरडे देयर विल बी अ क्लास फ्रॉम, ऑनलाइन होता है ऑफलाइन होता है सैटरडे वाला इरम?
सर अभी नहीं है,
सॉरी,
अभी वेकेशन है ना, तो अभी नहीं, स्कूल खुलने के बाद।
हाँ स्टार्ट होने के बाद ही, हम भी स्टार्ट होने के बाद ही की बात कर रहे हैं। एवरी सैटरडे
नहीं
आफ्टर
नहीं,
द स्कूल में होता है,
वो
ऑनलाइन होता है?
स्कूल में।
जाते हैं आप?
जी सर।
अच्छा,
जाना पड़ता
पढ़ाई
है।
होती है क्या?
हाँ, जाना पड़ता है एक्चुअली।
जाना क्यों पड़ता है, क्यों जाना पड़ता
वो सबको है, हमें मतलब ओनली वीक स्टूडेंट्स को नहीं है, सबको जाना पड़ता है।
है? हाँ
उसमें वो लोग नॉर्म, सॉरी,
हाँ, हम ये पूछ रहे जाना पड़ता है तो ठीक, मतलब जाना पड़ता है ऐसे कोई ना आपकी बंदूक लेके बिल्कुल आपको बोले कि चलो नहीं स्कूल जाना, ऐसा तो नहीं है ना। यानी आप लोग को सिर्फ छुट्टी फ्राइडे के दिन, ऐसा कुछ नहीं होगा, ठीक है। चलिए हर सैटरडे 10 to 11 AM KSA यू विल बी हैविंग अ क्लास, एंड ईच सैटरडे हम क्या करेंगे, आई विल बी टीचिंग D and F ब्लॉक छोटा चैप्टर, ठीक है। बायोमोलिक्यूल्स छोटा चैप्टर, ठीक है। तो these two chapters will be going on Saturdays, only these two chapters, ठीक है। ये हल्के हल्के चैप्टर्स हैं, इनमें मतलब सिर्फ आप कुछ मतलब कुछ लॉजिक्स तो हैं DNF ब्लॉक में एटलीस्ट, बायोमोलिक्यूल्स में तो कंप्लीटली फैक्चुअल, इट इज कंप्लीटली फैक्चुअल, यू हैव टू लर्न थिंग्स। तो धीरे धीरे आप इनको पढ़ते जाइए और इनके बारे में टेस्ट होता जाएगा ना, जो फ्राइडे टेस्ट होता है वो होता जाएगा, आपको चीजें याद हो जाएंगी। ठीक है, सो सैटरडेज को ये क्लासेस होंगी। अदरवाइज आप बताइए, छुट्टी ही नहीं है आप लोग को, फ्राइडे को सिर्फ छुट्टी है अब, ओनली फ्राइडे?
Yes, sir. Hmm.
नहीं खैर, ये तो हमने सोचा हुआ है अब ऐसे है।
Sir, 10 to 11 a.m. नहीं possible.
सॉरी व्हाट?
10 to 11 a.m. possible.